4, 3, 2, 1.
Good morning, everybody. I hope you are feeling well after yesterday, and welcome to the second day of the Xenium 2025. Grab some water or grab some beer if you prefer, and Sule is going to start the day with the seminar. Sule, tell us what the seminar is going to be about.
Okay. So my name is Sul. I'm from Alphenheid and the other TPOM, the practitioners of Lua Mega Demos. That's kind of how I started my adventure with TIC-80. So I've noticed there's a lack of a comprehensive TIC-80 tutorial. A lot of people want to get into fantasy console programming, and they don't have like an anchor point. So I'm gonna try to show some finer points of how to do stuff for the TIC-80, how to avoid some problems that might occur, how to optimize your code, because not every code is going to be great, and give you some ideas to put in your demo that you can show tomorrow, because you still have about 12 hours to make your combo filler for the fantasy console combo. So what is a TIC-80? Well, TIC-80 is really a virtual machine. It doesn't exist, which makes a kind of a hard sell for some of the sceners. It does have set boundaries and set rules, and that's why, as sceners, we love to break those boundaries and show that you can do a lot with that little thing that is not meant originally to do. So what are the specs? So it's as fast as your CPU can handle, which is really bad. I'm going to talk about it a little bit later. But basically, if you have a good one-core CPU, it's going to work really well. GPU is not really that needed. The display is 240 by 136 pixels, 16 colors, which is an asterisk, I'm going to talk about it later, in 2 VBanks. There's 16 kilobytes of RAM for sprites, which brings it to about 256 sprites. Those are 8 by 8. There's a tile map memory that we can use in a lot of other ways, which is about 2 screens worth of tile memory. There's a 4-track music capabilities. And we can put in about 64 kilobytes of code or 512 kilobytes of code if you have the Pro version. Now, what does TIC-80 support? It supports a variety of languages. The most popular options are Lua, Python, JavaScript. Some people like to do it in WebAssembly. Some people like to do it in more exotic ones like Fennel or Squirrel. But there's a comprehensive list of languages available on the site. If there's not, if your favorite one isn't listed, you can always implement it. TIC-80 is an open source platform. So it has its own IDE. You can code in it, you can edit the sprites, you can do the game map, you can do the sounds. It has its own tracker. So it's one in a package. Sounds great. What else? You can make your demos quickly. It's very easy in an hour to write a really nice effect. If you know what you're doing, of course. There's a large selection of languages, so if you don't know a particular flavor of a language, you can always switch to another one. It's very easy to pick up. It's a great console for this environment for the beginners. It's a great toy for the most advanced people. It's a lot of fun. there's a lot of built-in graphic capabilities you can utilize for your effects, for your games. So it's very comprehensible. Well, it's all in one package, so if you compile it yourself, buy it, or just download the normal version, you're ready to go. But there are some cons to it. Well, first of all, as I said, it doesn't exist. So a lot of sinners are going to dismiss it as just an environment. It shouldn't be like seen as something. There's no debugger. So you have to write your own debugging tools. The only thing you have is a trace function. So good luck with that. Debugging on TIC-80 is a nightmare, and I don't want to do it ever again, and I'll have to do it more and more. Putting your own pixel art on a TIC-80 is a nightmare, and you have to write your own exporter. There are two exporters I know. One was made by Mantratronic, the other by me. I have not released mine yet because it's I don't want to release really bad code, but eventually I have to do so. The non-pro version has limited capabilities. You can get only 64K of code and only one bank of RAM, which is very limited but good for beginners. And the biggest problem is like the speed of the console is limited by its CPU, so you can never be sure whether the problem is your PC is too slow or your code is just unoptimized. Because on the common machine, it can work very well. On your machine, it can be slow as hell. And the worst thing is sound capabilities are that of NS. And a lot of musicians just detest it, so good luck finding a good musician for TIC-80. Or you can learn music by yourself. So how is it organized? You have three spheres. One is RAM, which is sort of defined at the start. The other one is code, and there are variables. Now the whole thing is that the memory for variables is unlimited, RAM is limited, code is limited, but the interaction between them are more complicated. You can affect variables with your code, you can affect RAM with your code. You cannot easily transfer stuff from variables into RAM so it can be displayed. So it's best to push all of your raster graphics and sounds into the RAM. Anything like particles, voxels, similar things. Put it as variables, put it in your code, generate at runtime, because otherwise, well, it's reading that from RAM is going to be difficult. To look at stuff in the RAM or to change it, you have a variety of command, which is poke and peek, known from BASIC. You have a variety of them. You can poke peekabyte, a nibble, 2 bits, or 1 bit. So technically, you can like read from RAM, put in a variable, write to RAM from a variable, like so. But there is a problem with that. To make an image like that being displayed, it takes a lot of space in your code sector. So don't do that. There's other ways to display your image without resorting to this messy code. Or you can use compression, because compression is always a choice. And do that instead. But generally, the way to transfer stuff from variables to RAM can be achieved with code similar to this. And yeah, the variable space is kind of limited if you don't generate things on the fly. So how is that RAM organized? So you have your VRAM, which is your display RAM. It's in 2 banks. I'll talk about it in a little bit, what are the V banks. Then you have your tiles memory, your sprites memory, your tile map, which means that you can use the tiles and sprites to make sort of a scrolling map. You have your I/O registers, sound effects, music, persistent memory that we don't often use, and some sprite flags that for a demo scene developer, they don't matter for a game developer. So if you got the Pro version, you have all of these marked sections of RAM banked. That means that every you can like have like 8 sheets of sprite about that will give you 8 times 256 sprites. That's a fair amount. So you certainly with the Pro version you certainly can put a lot of art in your demo. And can we do something inside the RAM? Well, we can copy sections of RAM with memcopy function. We can switch the mangs with the sync function. The problem with the memcopy function is that it uses bytes instead of nibbles. So there's some problems with misalignment when you're trying to move sections of the screen using memcopy. So don't do that unless you're you know what you're doing, or just write different code. But the more important thing for us is that we don't usually use the tile map memory. And it's as big as 2 VRAM spaces, meaning that this could be our place where we can store the screen and manipulate it. In other words, it's real estate. We can use it for a lot of things. I'll talk about them later. So the screen buffer is organized like this. There's VBank 0, which is the background with a border. And there's a VBank 1, which is an overlaid foreground that is that has 1 color of transparency, and otherwise all 15 colors are opaque in relation to VBank 0. We can plot a pixel on a selected VBank using either pix, which is range checked, sanitized, no problem, or you can poke a specific RAM memory. Now, if you've ever done assembly on an old PC, you would prefer to do it with a poke, but honestly, when I try to profile it, I don't know whether that's faster or slower. So results may vary. You have to see which one is more applicable to your code. That's the main problem of TIC-80. Which is faster, we just don't know. So we can switch the VBanks with the VBank command. So, or we can check which VBank are we writing to with the VBank command. But there's a little bit more. There are registers we can use. We can change the palette. We can change the border color or the transparency of VBank 1. That's the same register, but depending on which VBank is chosen, that register controls something different. We can do a horizontal shift, so we can basically scroll the screen left or right by 127 pixels, or we can vertically scroll it by the same amount. Now, I said before that we can have 16 colors on a display. That's not true, because if we combine the 16 colors from VBank 0 and 15 colors from VBank 1, which has its own palette, we get 31 colors. So that's we're getting close to the Amiga. And there are some people that just use math and pixels to do stuff like this. That's out of my league. And I really applaud the man that wrote this, because it runs on a decent speed and it's real-time ray tracing. The only command he uses is poking a specific the screen. The rest is just math and Lua. So even with the simple poke or pix, you can do a lot on TIC-80. But there's a little bit more. So for example, you can take VBank1 as your main canvas. You can then copy the contents of VBank1 to the game memory. And you can then switch to VBank0 and copy that memory from game map to VBank0, which has a darker palette. Now we go back to VBank1 and we start carving out shadows from VBank1. And that way you can do like very cheap two-dimensional shadows, or three-dimensional if you're feeling particularly adventurous. But that's an insanely cheap way to do a lot of things with very limited tools you have. Now, the other thing you can do is it has a specific function when scanline is being drawn. You can change some of the register. You can change the palette registers. You can change the border color or transparency on the fly. And you can do little horizontal shifts. So you can wobble the screen a little bit. So technically, with the palette changing, you have 31 colors times 136. That's about 8,000 colors you can display at the moment at TIC-80. Does that mean we're getting closer to Amiga capabilities? Not even close. I'm sorry. It's not going to be as good as Amiga ever. But let's get more adventurous. Let's get into the built-in graphical function. So you have your collection of primitives. You have your lines. You have your bar, which cannot be rotated, unfortunately. You have your circle drawing routine, which is fast. Oh, that's the only way you can do it. And you have your ellipse, which is also a fast function. And you can wipe your screen really fast. Now, the uniting factor amongst these functions is those are all fast functions. So don't reinvent the wheel unless you have to, because sometimes you just have to when you want, for example, radii that are floats, or a rectangle that rotates. Sometimes you need to rewrite those functions. But those primitives are there so you can do stuff fast without having to resort to difficult code, and it simplifies your code. Now, TIC-80 has capabilities of drawing polygons. You have your unfilled polygons, you have your filled polygons. But there's no Z buffer to be found for those polygons. And there's a little bit of a weird rounding error on vertices. So if you, for example, say, draw a polygon from, let's say, 1010, 1020, and let's say 2020, that last bit is going to show, the last vertex is going to appear at 1919. And there are a few things to get around it. Some people just add just half to any vertex to make it sure it adheres with it, or just run with it and see if that works. There's a few approaches. Find out the best that works for you. But just keep that in mind if you're ever doing polygons.
Sorry, is it just solid color?
Hmm?
Is it just solid color, or can you do grow, interpolate?
Ah. One of them is filled, one of them is unfilled.
No, but can you have like a different color at each vertex?
Oh, yes. Yes. Yeah, I forgot to mention that. Like you can define color. Every primitive, I forgot to mention, every primitive you can define color of a primitive. That's not a problem. No. Only
Like you cannot
the full
make a
color.
gradient. You cannot
You
get go route
you cannot
shading for free,
find
right? It's basically your question is about can you do go route shading for
no,
free?
you cannot do that unless you code it. So yeah, there's some. That's why I'm saying it's like a very neat thing, but there are some things where the primitives are not enough. So you need to write your own code because some people just wrote their own 3D engines without using these primitives to have go out shading or more complex things that you cannot do with those polygons. Now, I was saying that you cannot rotate a bar, but you can totally get two tries together and have a quad and animate it well without a problem. But I think like 2 years ago, another function was added, which is a texture polygon, which it's texture with perspective corrected, so you don't have to worry about your textures being squashed. But it's z-buffered, but it's non-accessible. You can only wipe the z-buffer with the CLS command, so that's a problem if you put too many polygons. The source of the textures, you can source from your sprite RAM, your tile RAM, your game map RAM, and your screen RAM. So there's a lot of sources from the textures, and you can make a lot of neat effects using them. I'll show that later, how you can do large parallax scrolling using screen RAM as your source. There's still rendering errors. That means that UV mapping is kind of difficult if you just want to use that as a as a flat, as totally flat surface. And because normally the try function does not have a z-buffer, you can just make a small texture 2x2 of a single color and use tt-try as a replacement for the try function with a z-buffer. So you can get around some limitations by just smartly using the tools at hand. As a demonstration of how I've used texture polygons, the falling stained glass from Demonique is done using polygons, sourcing the stained glass from the Sprite RAM. That's why you have all of those rotations and this. But the problem with that is UV mapping of that was in the same shore, and I spent, I think, 2 days making sure there's no errors in it. So that's the downside of using the function for effects like that. And TIC-80 can also handle sprites. You have the sprite function, meaning that there's only 8x8 sprites selected by an index number. Scaling is by integer, so you can make 1x, 2x, 3x, 4x, etc. Turning 90 degrees, you can flip them, which means that you cannot really do nice rotations with them, stretching or shrinking. But because they're using indices, it's very easy to make frame-by-frame animation or sprite compositing with that function. But what if we want to do the stretching? What if we want to do rotations? Well, we can use two T-tries composited into a quad, and then basically have that stretched and shrunk, rotated like the caterpillar there, which is just taking sprites from the RAM, stretching and shrinking them to simulate motions. But of course, that's the problem. Again, the problem with vertices rounding. So UV mapping is a hell.
Is it possible to modify sprite in on the fly?
Yes, yes, it is. If technically you can, for example, switch the bank on the fly to get more sprites, but you can do a write to the sprite memory on the fly because during bike jams, for example, there's a strict rule of not using pre-made assets in form of sprites. So, for example, you can write a neat little sprite packer and unpacker that on the fly modifies the sprite memory. And if you're using, for example, the SCN function or BDR function, you can technically swap out the sprite memory mid-scan line to get yourself more sprites per screen. So that is possible.
Can you do sprite multiplexing?
I haven't tried it yet. I try it, but I'll see if that's possible. Because I was thinking about doing the same thing, but still haven't had the time to try those capabilities.
I think it's unusual because you do multiplexing where the limit of sprites is quite low, like 8, you know, right? But here you can have a lot already out of
Yeah,
the box,
but
right?
if you want
But
to,
on the other hand, they are small. They are much smaller.
they're small, and if you want to do like really complex animations, that's not enough. So you have to be either smart about how you compress your frame by frame animation, or you have to maybe do rewrites on the fly. I haven't tried that because I haven't gotten to idea that would use such techniques.
In general, it's actually funny that the sprites is 8 by 8, so they are like tiles. I'm thinking, you know, like NES, but they can be positioned with the 1 pixel accuracy, right? But
Yes.
you may think about them as a tiles that are basically not fixed to 8 by 8 grid, but can move around. And this effect you show is kind of, you really get a spirit how to use for your advantage, right?
Another interesting thing is that to preserve sprite memory, because that's a really large sprite of the goat head, I just put into sprite memory half of the head, mirrored it using the sprite command, and just have a symmetry point. It works. It breaks the limitation. You have the lip syncing even. You can do a lot of things just with the basics if you manage your memory smartly. So neither of those approaches that I just talked about are correct. Find the best approach to a problem and use it. Because I've seen some people just dismiss the sprite command, well, because it doesn't have all of those rotation capabilities, etc., etc. No, it's still useful. Just use it when it's actually usable. But okay, I've talked about the basics. Let's do some effects. So this is from the Assembly TV Mega Demo. It has copper bars and a cheap water reflection. And let's see how we can do those. So we start with SCN, because that was on the older version of TIC-80. So copper bars is very easy. We just switch the palette registers per scan line just for the sky. But how would we do the roto reflection? So we can create a palette from a certain scan line that is darker than the sky palette. And then we can start sourcing lines of lines of screen from like multiples of 3, I believe I was using that, and just copying them. But then we can add the register to shift everything left or right and get that little nice shimmer to make it look more like water. And there's no, I don't think that uses that much CPU power. So it's a very cheap way to do really nice reflections. A lot of people have done that for their sea scenes. So it's a well-known effect by now. The same with the copper bars. It makes for a nice sky just to like stretch out that gradient of one color. But what about auto reflex? How about if we do a roto zoomer? So roto zoomer is incredibly easy. Back in the day, people have been just doing the usual thing, which is calculating the pixels, plotting them. We're doing just 2 tries that are stretching and shrinking and moving, which is very easy. They're sourcing the sprite memory for the source of the image. Everything else is just tiling them, stretching, shrinking them, rotating them. This is fast. That's why you can put a lens effect over this and not have the whole demo slow to a crawl. Another interesting thing in this particular effect is I'm using the VBank 1 to do that black background and just cut out a circle using a transparent color just to show that roto-zoomed lens. So that's how you can do, for example, masking using VBank 1. What about parallax scrolling? Well, we can do that as well. I was told it was impossible to do large parallax scrolling on TIC-80 because of limitations. Well, I've done it. So this is this is 2 pictures in the game map memory, which are 2 parts. Excuse me, 3 parts of our scroll. So what we are doing first is we're taking the left picture, the foreground, and copying it on VBank 1. We're going to then go to VBank, or VBank 0, sorry. And then we go to VBank 1, copy the upper picture here, so the clouds, on the upper part of VBank 1, because the lower part of VBank 1 will be our foreground. Now, using the TTRI function, we're sourcing this VBank 0 screen and putting together basically 2 large planes together as a scroll. We're defining where the scroll is right now, but we're sourcing the graphics from VBank 0. Okay, we've used that. Great. So what do we do now? We go back to VBank 0, and then you then copy the clouds to a position so we can scroll those clouds as well. And lastly, we go to VBank 1, we copy the lower right image in the upper section where the clouds were. And again, we're using TTRI to make like a scrolling plane back to back those two pieces and scroll it. So we can use very large images, and we can do this many times. So we can like have just bits of screen reflecting every parallax layer. So we can basically have as many parallax layers as there are scan lines. It's a very efficient technique. You can use very large images for that, and if you can do stuff on the fly where you're swapping out memory, you can even extend it more and more. So it's a very efficient technique. It proves that large picture scrolling can be done on a TIC-80, and it never was in the manual, so good on us. So how do we do particles? So we can have, at least in Lua, because most of the stuff is written in Lua, we just make an array. We then, after creating the array, we just cycle the particles slowly, give them speed, give them spread, some randomization to it. And using Lua, we can then remove the particle that is the farthest, and then insert a new particle with a starting point from where the particles are. And we can do that, we can cycle that function over and over again and just read where the pixels are and draw them. It's very fast, very efficient. This code I've made it's not the full code because there's a little bit of setup on boot. It takes 700 bytes, so you can make really neat particles with very compact code on TIC-80. Just use arrays and use table functions. And how do we make a 3D tunnel fast and cheap? We use the same principles as with the particles, meaning that we just create an array that will create on the fly sections of the 3D tunnel by eliminating sections that would appear behind us and adding new sections far off in the distance. And cycling that, we can make a really neat 3D effect on the chip. There is one problem though. TTRI rendering does not know if it should be drawing stuff behind us. So you need to come up with your own function that will be clipping the polygons. And that's a big hurdle with doing any kind of 3D rendering on the TIC-80. If you would want to do models or like any kind of 3D stuff, you have to write your own renderer. And it is a very, very difficult thing to write it fast. And one more thing, if your code is too slow, just add local keyword to a variable. It just works. Trust me. That's how we managed to fix some of our mega demos because the code was way too slow. So we started adding local to some variables. It sped up. We don't know how it works, but trust us, it just works. And if you want to know more, a lot of stuff that we do for TIC-80 is open source. You can go in, you can look at the code, you can learn from it. The problem is the starting point, which I hope for some of you this presentation is a great starting point. But there's a lot of code on TIC-80.com. There's snippets of code from our weekly byte jams on livecode.demos.org. Go, look at the code, learn from it. There's fantastic write-ups on basics, on Tiny Code Christmas, on Love Byte. And every Monday, we're hosting our byte jams on Twitch. Not every time they're TIC-80 related, but sometimes they're shaders. But if you want to try your hand at like coding of TIC-80, that's a great place to start. You can observe how people are writing their code. You can see those effects evolving on time. There's a large video archive of these events, so you can profit from that. And lastly, I wanted to thank my friends from the Field Effects Discord who got me into it, TIC-80 coding, helped me a lot with understanding it, hosted those byte jams, did a lot of heavy lifting in making stuff for TIC-80, or just making seminars, making tools. There was this year at Xenium, there was supposed to be a byte wall that people can just like sit at TIC-80, write your little effects, try them out. Well, it didn't happen. Maybe next year. The invitation for that is still open, but hopefully next year we'll get the byte wall. People can try it. It's a great way to learn. And that's all from me. Any questions?
Thank you. So what is the reference platform? Like when you said that the code is too slow, what are you measuring against?
See, the way I usually do it, because there's no profiler. That's you have to write your own. But because the music is so the limit of the platform is 60 FPS, right? So you can try to see if the frame rate is dropping below 60 FPS,
On
or
your,
which is a more interesting way, because the way that the music system works is that it's feeding music every frame, right? Like bytes every frame. So if you notice that music is breaking up, that means that the code is too slow. That's how I basically debug it. If the music is breaking up, that means the code is too slow. I need to change some.
so how do you know that, like for you it works great, but like what if someone else runs it and it's too slow on their machine?
You have to write your own profiler. That's the problem. You don't have you have. That is the problem with coding on TIC-80. You have no idea how fast the code is because you're writing it on your own PC. So you're thinking, okay, the code is fast on my PC. A friend runs it and says, no, too slow. Like the lens effects I've done, for example, early on my Windows 7 PC would slow the entire code down. If I used a Windows 11 PC, even with
it's going through GPU, can it go through like software rendering on some other machine? Or is it always software rendered?
Well, technically, okay. So because this is going into the internals of TIC-80 as a program. So technically, everything is done using the SDL library, right? So by default, like all of the graphics function that are built into TIC-80 are GPU accelerated by design. That's why I'm saying like the primitives are fast, but sometimes you don't want to use primitives. For example, as you said, like polygons with guard shading, yeah, you have to program that yourself.
Okay, so is that guaranteed on every platform that supports TIC-80 that like this is going to be on GPU?
Come again?
Is it guaranteed that like on any platform that runs TIC-80 that like triangle will always be GPU accelerated? Or can it be that some TIC-80 implementation on some platform just does it in software?
Technically, all of the ports of TIC-80 are made so it guarantees their compatibility between the platforms. So something that runs on Linux should in 99.999% run the same on Windows. The problem is the speed. I know that the Windows 7 or the Windows XP rather, the 32-bit version of TIC-80 is for some reason slower than the Windows 10, 11.1, or what they call the Windows 16 4-bit, which is a lie, but whatever. But all of the graphic functions, they render the same on all platforms. Because you can run TIC-80 in a web browser. If anything fails, you can always run in the web browser.
Sorry, if anyone else. I just wanted to ask, what kind of testing do you do before you release? Like, how do you guarantee that your TIC-80 program will be reasonably performing on typical TIC-80 machines?
I pray to God that it does. I know, no, it's a bit of a shitpost answer, but trust me, I just hope it runs well on the combo machine because there's no way of telling beforehand if it does.
Can you say more about the audio system, the music, and why it has a bad fame?
Okay, so I'm not a musician myself, but I can say at least what are the hurdles. A lot of people don't like the fact that there are no predefined waveforms. You have to find your own waveform, just draw it. Basically, like I believe in, I think it was in Fast Tracker 2, where you could drag, yeah, like ancient stuff. So you have no predefined sign, sawtooth, square, you have to draw it yourself, which a lot of musicians hate because they cannot get that perfect sound they want. There was an idea of making just a pack of predefined waveforms for musicians to just use, and the fact you can draw your own waveform is great because you can. Don't like that. People are really want to work on their programs, don't really want to reuse that tracker, which is just suboptimal. As a pixel artist, I can tell you that the sprite editing capabilities of TIC-80 are one of the worst I've ever seen. That's why I've made my own import tools, because I was just so done with like drawing in TIC-80. I just do everything in Sprite, convert it, paste it into Lua code.
Okay, so Sprite tools are bad and audio stuff is bad, so everything is bad there.
No. You can still do a lot with it.
Okay.
Like it's like marriage. Like sometimes you have to overlook things, right?
Okay, got it. And as for audio, could I compose outside and just do everything audio related outside using my
See,
own tooling and import it somehow?
There was an initiative. I don't know where it went. That someone was programming a tracker to do stuff outside of TIC-80 and then import it in. I believe Envis would know a little bit more about that. I would have to ask him. Because someone was working on that, I know that. Same with the pixel art tools, like I'm technically working on that importer, basically, but the one I wrote is in Turbo Pascal 7, so yeah, not a whole lot of people want to run DOSBox to just import pixel art into TIC-80.
Good stuff, thanks.
Any other questions? Okay, thank you very much. That was really nice presentation. Thank you. So now use all this knowledge, and you still have like 11 hours to code your release for Fantasy platform demo. You have time until midnight today. I hope to see like 3, 4 new releases thanks to this presentation. Friends,
Thank you very much,
nice.
Sule.
Very nice.
Once again, round of applause. Woo!